Namaste and welcome back to our channel Qubit Educational Services. In this video series we are discussing the IISER Aptitude Test 2021 Physics MCQs, and this is our fourth MCQ which we will solve in this video. It is based on the idea of capacitance and thermal expansion of solids. The problem is a capacitor of capacitance C consists of two large parallel metal plates, so it is a parallel plate capacitor. The coefficient of linear expansion of the metal is alpha. What is the change in the capacitance? What is the change in the capacitance? If the temperature of the plates rises by delta T while the gap between the plates is kept fixed. To begin with, let us recall in usual notations the formula for capacitance of a parallel plate capacitor. It is epsilon naught A by D, where D is the separation distance and A is the area of the metal plate, okay, any one. Now epsilon naught is not going to change because of temperature. D is also not going to change because of temperature, because we are not given how thick the plates are. Okay, this D is not the thickness of the plates, this D is the separation between the plates, if you know. Okay, and anyways they are saying that gap is fixed, so D is fixed. So whatever change that will take place in the capacitance, that will be because of area. Okay, now you know that these metal plates are going to expand if the temperature is rising, isn't it? So the options C and D must be ruled out, because if capacitance is directly proportional to area and if area change is positive, then the capacitance must increase, so the change will be positive. So it will be either A or B, we have to decide that. Okay, now they have given us coefficient of linear expansion, but in this case we have to consider the coefficient of areal expansion. Okay, we have to consider the coefficient of areal expansion. Okay, so what is the coefficient here? That coefficient is beta, let's say. And how do we define it? Okay, how do we define beta? Beta is delta A by A into delta T. Okay, delta A by A into delta T. Just similar way we define alpha. Alpha is actually delta L upon L into delta T, but in this case, okay, it is delta A upon A into delta T. Now the most important formula to solve the problem is the relation that you can develop between the coefficient of linear expansion and the coefficient of areal expansion, and that relation is beta is equal to 2 alpha. This is by far the most important relation. Well, you need the capacitance formula of course to begin with, but this is the relation. Okay, now this is going to tell us by what amount will the capacitance change. Okay, so if C is epsilon naught A by D, I can say that the change in the capacitance will be epsilon naught by D into delta A. Okay, that is, well, actually just a differentiation, but we are not writing the variable of differentiation. So delta C is epsilon naught delta A upon D. Okay, now can we find this delta A? Of course we can find this delta A. Using the coefficient of areal expansion formula, what is delta A? It is A beta delta T. Okay, A beta delta T. But what is beta? Beta is actually 2 alpha. Yes, and once we get it, then our job is done. Okay, delta A is A 2 alpha delta T. So let us substitute it here. Epsilon naught by D into delta A. What will you substitute? This part. So it will be A 2 alpha delta T. But what is epsilon naught A by D? That is the original capacitance, 2 alpha delta T. So C 2 alpha delta T will be the change. Okay, so there only in option A we have that 2 alpha delta T C, or C 2 alpha delta T. Yes, so correct option is